Incoming message.
What's Gucci, everybody? It's AJ back again, and I hope you're having a wonderfully great, fantabulous day. And today I want to be talking about the hexadecimal system. I talked about the binary system last video, which I'm trying to upload right now. And I want to talk today about the hexadecimal system, which is different from binary, which is ones and or zeros, and different than the decimal system. I have such bad handwriting, I should consider not doing this. The decimal system, which is zeros, ones, twos, threes, fours, fives, six, sevens, eights, 9, and that's it. The hexadecimal has an ability for 16 different inputs. It has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. So yes, don't get shocked because we have letters now. I know math started getting complicated when, math started to go out with the English language and you couldn't understand anything anymore, and there were all these very weird things, but that's what we have in hexadecimal. Yes. And hexi is base 16, whereas binary is base 2, decimal is base 10. And all you have to do is you have to change your thought process from base 10 to base 16, and hopefully I can show you how to do that. So commonly, something I just found out today is that hexadecimal numbers are usually referred to with a 0x in front of them. And this just is defining that whatever you're about to see next is a hexadecimal number. So the 0x does not mean anything except it's telling you that it's a hexadecimal number. So don't worry about the 0x. But if I said 0x AF, the AF would actually be the number that it's referring to. Now again, it's important to know that hexadecimal can be converted to decimal as well as binary, decimal base 10. So, for instance, let's convert AF. Now, as I said, hexadecimal is a base 16 language. So, we're going to do the same thing we did for binary and decimal in my binary video, except I'm going to do it now for hexadecimal. So right now I have AF. And since it's base 16, I know the rightmost digit, I'm going to have 16 to the 0, and I'm going to have 16 to the 1. And right now, and like I saw here, I'm just going to multiply them and add them all up. Multiply them separately and add them up. So one quick note that I forgot to mention is that, as you saw here, I drew all the numbers that we can use in hexadecimal, but you may be confused by these letters. Well, essentially, what's the dealio in hexadecimal is that these letters essentially correspond to 10, 11, 12, and 13, 14, and 15 when you're converting them. So that's always good to remember. So when I look at A and I'm thinking of trying to convert it, I should be thinking of 10, 11, 12, and 13 in decimal. So that's important to note. So it goes up to 15, which is F, and it's something important to think about, that there is a value after 9, which is 10, which is A. So right now I have, since A means 10, it's 10 times 16 to the 1, which is 10 times 16, which is 160, I believe. And then I have, F is 15, as I just showed you, is 15 times 16 to the 0. And anything times 16, anything to the 0 is 1. So this equals 15 times 1. 15 times 1. Wow, I think my YouTube video just got uploaded. And it equals 15. So 160 plus 15 is 175. And so that is what AF equates to in binary. Ooh, we did something. Okay, so now you see I have AF. And again, I could do this for a lot of things. Now I'm going to show you how to convert a decimal number to a hexadecimal number. And by doing that, I'm going to try to show a little bit of a complex case. We're going to convert the number 314,156 to hexadecimal. So I've got 314,156. And what we want to do here is we want to use the hexadecimal digit representing the least significant digit when we generate the error. What we want to do is repeatedly divide the decimal number by 16 and using the remainder as the digit to put into hexadecimal, and then keep on dividing that number that we came up with as the divisor. I know that may not make sense, but let me try to explain it to you. So with this number, the first thing I'm going to do is I'm going to divide it by 16. And that is going to give me $19,634. I've already done this in my head, times 16 plus 12. So 12 is the remainder. And that is the remainder is the first digit I'm going to put in the hexadecimal system. And as we can see here, 12 is equivalent to C. So C is going to be my first number in the hexadecimal system. Now I have this number, which is, again, 19,834. I'm not going to worry about the 12 now. I just use the 12 to make the hexadecimal number. But now I'm going to take this number and divide it by 16 and get the remainder. So after dividing 19,634 by 16, I get 1,227 times 16 plus 2. And anything below 9, anything 9 and below is just the number. So that's 2. So that's 2. And now I'm going to divide 1,227 by 16 again. Get 76 times 16 plus 11, which refers to B. Gosh, I'm running out of space here. And now I'm going to, again, take that 76 divided by 16 and get 4. Plus 12. And the 12, again, refers to C, as we showed above. Let me put this in a special box here. And now I've only got a 4 left, and I'm going to still take that 4 and divide it by 16 to get the remainder, which is 4, and that will be my final answer. So this hexadecimal number can be expressed as 0x4cb2c. So that's how you express a binary number, a decimal number in hexadecimal. You just keep on dividing by 16, take the remainder, and keep on taking whatever the value got, the, integer value, and putting it again back into the equation of dividing it and taking the remainder and interpreting those digits as what you will use to make up the hexadecimal number. Because since you're constantly dividing by 16, you're never going to get a remainder of 16 or over, so you can always use this system to interpret it. Okay, so now I want to show you guys how to add hexadecimal numbers. As you'll see, it's pretty easy as long as you remember to carry the 1 and to be in the relative perspective of thinking about 16s instead of 10. I'll show you what I mean here. Right now, I'm going to add the numbers 5, 0, 3c and x8. I'm going to erase these and put x8. Remember, the 0x just tells you it's in the binary perspective. It does not actually mean anything. So as you can see, I had this c here, which I'm not going to erase, and I'm adding these. And what I want to do is I want to add these and output them in a hexadecimal format without somehow transferring them to the decimal system and then putting them back. I think that would take a little bit longer if we actually know what we're doing. So remember that I'm only carrying here if I go over 16 because it's relative to the power of 16. I mean, not the power, but to the number 16. It's in base 16. So right here, I have this 8 and this C. And we learned earlier that C is equivalent to 12. So I'm going to make it 12 over here. And what I like to do is put the 12 in the same spot. And that's okay in this case because this is hexadecimal and not the decimal system. So 12 is less than 16, so it can be in one spot. It can have its own spot. That's why it's represented by C. It just may look a little confusing, but just remember this is in a solo spot because it could also be interpreted as C. So I have 12 plus 8, which is equal to 20. So what I'm going to do here is I see that 20 is 4 spots over 16, so I'm going to put a 4 here because it is 4 spots over 16, and then I'm going to carry the 1, which is to the 3 here. And now I have the 3 here, which is 1 plus 3. Simple enough. I've got the 3 there, and now I've got this 0. Again, I just bring the 0 down because I'm not adding anything to it. I'm not adding these two because they're just there because I put them there to show the units. You need this here just as units are used to show kilograms. And the 5 doesn't have anything to add here, so 5, 4. So my answer to the addition of these is 5x, 5044. And what I want to show you here is instead of taking the time to convert these, I have a converter here. And what I want to do is I want to show you that that is indeed true. So I had 5030C, that's 20,540. And I had 8, which again is just equivalent to 8. So the answer should be 20,548, I believe. Did I get that right? Oh, oops, I did not input the right hexadecimal. 5044, and I get 20,548, which is the correct answer. Guys, I hope you enjoyed this tutorial as much as I did, and I hope you have a great day. Thank you.